Write down this week's planner: Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Today you are having test on measurement, scalar vector, kinematics, circular motion, gravitation. This will be 21st 6, only law of motion. Only law of motion. Here, we'll send the sheet, we'll practice 1 to 20 sums from that sheet. Then 21 to it should be 70. Then 71 to 120. So, 121 to 170, 175, 171 to till end. Here, new sheet given that is that. These are all law of motion. Law of motion, law of motion, law of motion, law of motion. One more sheet of law of motion. I don't recollect the number of sums, so I told new sheet law of motion. Monday test on law of motion. And then we'll start here work, power, energy. That is our last part. Write down this. Can I clear this everything from the screen?
Yes.
What are different types of forces? Do you know different types of forces? Yes, anybody knows different types of forces?
So contact force, non-contact force.
Contact and non-contact are two types of force. Contact forces of how many types? Normal reaction frequently will have normal reaction. Then it is tension. Then it will be restoring force. And then it will be force due to collision. And
So friction.
force due to collision, restoring, yes, friction. Non-contact, this we have done separately. Gravitation chapter में gravitational force, electrostatic force, magnetic force. We have done all this separately. So just write down, then one by one we are understanding the nature of this before we start with the next.
Done, sir.
normal. It is always perpendicular to surface at point of contact. That means if this is horizontal surface, this is point of contact, normal reaction will be perpendicular to the surface. Weight is acting downward. So actually this body is giving normal action as normal reaction. This will give reaction. Generally we talk about forces acting on the same body. So normal reaction offered by the surface and its own weight mg. But actually every force is having equal and opposite action and reaction. So on this surface it is normal reaction downward and on the body upward. This is direction of normal reaction. If this is circular surface, here I place the body, then normal reaction will be perpendicular, that means passing through radius. Second is clear, second one. Hello?
Yes, sir.
In third case, this will be the normal reaction perpendicular to the surface. Hello?
Yes, sir.
If this is the surface, where will be the normal reaction? Perpendicular to this surface. So for vertical surface, it is horizontal. For horizontal surface, vertical. Circular surface, radially outward. And for inclined, perpendicular to the surface. Draw this flow diagram.
Done, sir.
Tension T. It will act on string. It will act on rod. It can act on chain. These are three cases: string, rod, chain. So if this is rigid support, a body of mass m is tight, we want tension on the string. So weight is acting downward, tension is always away from the body. So from here it is acting away. Suppose this is mass m, this is force by which it is pulled, so tension will be away. So just remember T is always away from body. What will be tension acting here? Direction. Force applied is here. This is the string. So if I call this as acting away T, here it will be away from this body, away from this body. T1, T1. Here I wrote T1, T1, here I wrote T. If strings are different, then tensions are different. So while notation will take one as T1, T2 or PT1. Value I don't know, may or may not come in. Just copy this much again. Done.
None, sir.
Rigid support. Here we have a body of mass M tied to this horizontal string. Now here weight will be acting downward, tension from here. Both strings are different, so this is T1, then this is T2. At this end away, this will be T2, this end away, this is T1. Follow the distribution of tension and on the two string. Hello?
Yes,
Distribution
sir.
of tension followed. In this case, can you suggest tension का direction कैसा होगा? So if I start from here, this is tension T1. Here shall I call T1 or T2? This one?
T2.
T2 because it is different string. ये T2, इधर T1, इधर ये T3, इधर ये T3. शायद डायरेक्शन समझ गया अभी आपको.
Yes.
Copy this to then free body diagram will see.
None, sir.
Have you heard about free body diagram? Free body diagram, FBD. Yes, have you heard that?
Yes.
Now in this always will take body का point mass, not full body का mass, point mass. Second, we will show all forces acting on that body. All forces acting on it. Third, forces are always taken with respect to reference frame. Reference frame means observer who is observing from where? Observer from ground, also called as inertial frame. So we are talking about forces acting on inertial frame of reference. Suppose I consider one body here of mass m. Somebody is standing outside and observing this body. So for him, his weight is acting downward for this body and normal reaction upward. So we can say at equilibrium, N is balanced by mg. This is the meaning of it. Suppose this is one inclined surface. This is normal reaction. This is mg. So at point mass, normal reaction and mg they are inclined. Copy. Is it?
Yes, sir.
Suppose this is pulley. Here we have mass m, m1, m2. We are interested in forces acting and draw its free body diagram. So here its weight is acting downward m1g, इसका weight downward m2g, tension T1, or you can call T. This is also T. This is same string, so T. And for this, away from the body, tension T1 and 2. So this is for me A, this is B, this is C. So for A, free body diagram will be M1G downward, T upward. And for B, M2G downward, T upward. And for C, T downward, 2T, that is T1, which will be 2T1 upward. Have you followed this three? Hello? Followed this three part? Hello?
Yes, sir.
Yes, sir.
Just draw this diagram and this free body diagram.
None, sir.
So with this, you got basic idea, direction of tension, direction of normal reaction, and free body diagram. Now we are using this in Newton's first law of motion. What is Newton's first law of motion? Every body continues to be in the state of rest or uniform motion. Every body continues to be in the state of rest or uniform motion in a straight line unless until acted upon by external unbalanced force. That means summation of all the force is zero, then body will be said to be under equilibrium. So Newton's law states that body is under equilibrium if external forces are balanced. Okay? Hello? Hello?
Yes, sir.
Just write this statement, then based on this 4-5 sums I am doing. I think you have written. Can I clear?
Yes.
These are two bodies. One is of mass 2 kg, other is of mass 5 kg. Find tension in both strings for system to be in equilibrium. So if I consider first body, this is tension moving away, tension moving away, here tension moving away. So free body diagram for 2 kg will be T1 is acting downward, T2 is acting upward, its own weight M1 1G is acting downward, correct? Hello? Hello?
Yes, sir.
Yes.
So can we say here T2 must balance T1 plus M1G? Then the three body diagram for 5 kg if I draw, then weight is acting downward, M2G, T1 is upward. So it will be T1 acting upward and this M2G acting downward. So T1 is nothing but M2G. Question 2. We are interested in T1, T2. So we can say T2 will be T1 which is M2G plus M1G. M2 5, M2 5G plus 2G. So 7G, that will become 70 Newton is tension T2. And T1 will be 515. These are the two values of tension at equilibrium. So this three body diagrams you are understanding. Once you have understood, we will not draw separately. We'll see from the main figure on. Hello, everybody has followed the diagram?
Yes, sir.
Okay. Yes, not done. Hello, completed?
Yes.
Do you know this 30 triangle का अगर side मालूम है? If this is one triangle having side 3, 4, 5, this is 90 degree. Then you know this angle will be how much?
37.
37 degree, and this is 53 degree. So in 37, 53 degree, 90 degree triangle, side opposite to smaller angle is 3, larger angle is 4, and hypotenuse is 5. So what will be sine of 37 here? 3 by 5. And cos of 37, 4 by 5. Sine of 53, 4 by 5. Cos of 53 is 3 by 5. So cos के लिए larger angle, smaller value. Smaller angle, larger value. तो ये जरा एक नोट लिख लो, बहुत बार वो लोग ऐसा दे सकते हैं. Angle 37, 53, you should remember it is 3, 4, 5 का side.
Done, sir.
Sine 37, 3 by 5. Sine 53, 4 by 5. Cos 37, 4 by 5. Cos 53, 3 by 5. Angle is 37 degree. This is 5 kg mass connected to horizontal string. Find tension in both strings. You will try on your own? Will you try on your own? Hello?
Yes.
Just try by your own.
Done, sir.
All of you got that answer? Just check. Is it same answer you are getting?
Yes, sir.
Body of mass root 2 kg is tied by two strings. Find, this is making 60 degrees and here it is 30 degrees. Find tension in both strings. Yes, try. Forces acting will be its weight, downward mg. Tension you can take here T1, this is T2. Now try. I'm not drawing separate free body diagram क्योंकि अभी idea आ गया. T1 cos 60, this will be T1 sin 60. Here it will be T2 cos 30 and T2 sin 30. Yes, what is the answer? Got the answer?
2 by root 3.
How much is T1?
So both are equal in.
Both equal you are getting?
Yes.
No.
No, sir. T1 is root 3 times T2.
Barabar. T1 is root 3 times T2, correct. And what is T2?
5 root 2.
No, T2 is coming 5 root 2.
Yes, sir. 5 root 2.
Yes, T2 is 5 root 2. T1 is root 3 times T2. That will become 5 into root 6. Did you get, all of you are getting same?
Yes, sir.
Okay, I will just solve it if you have not got. T2 cos 30 is T1. So T2 root 3 by 2 is T1. Therefore, you can leave this as equation 1 if you want. T2 cos 30 is T1 cos 60. Cos 60 is half. So we get T1 is root 3 times T2, equation 1. Then for upward force, T1 sine 60 plus T2 sine 30 equals to mg. So T1 sine 60 is T1 into root 3 by 2 plus T2 sine 30 is half equals to root 2 into 10. Okay? Hello? Hello?
Yes, sir.
Yes. Yes, sir.
So this will become root 3 times T1 plus T2 is multiplying 20 root 2. Then if you substitute, I think you will get the required answer. Should I solve or you got now? Root 3 T1, root 3 T1 plus root 3 T1 is root 3 times T2 plus T2 will become 20 root 2. Root 3 is 3. So 4 times T2 is 20 root 2. Therefore T2 is 5 root 2. Then substitute, we will get here T1. Shall I clear now?
Yes, sir.
This is inclined plane. Body is tied to the string. This angle is theta. Find tension in string and normal reaction on mass small m if m is in equilibrium. What are the forces acting on the block? Its weight mg downward. This is tension T, normal reaction N. What will be the force acting on downward direction along this axis? This mg, if I resolve into two components, this is theta means this is theta, so mg cos theta, and this side will be mg sin theta, correct? Hello?
Yes.
At least now you can manage that T will become mg sin theta, this is tension, and normal reaction is mg cos. This is to answer mg sin, mg cos. Done. Next one I'm doing.
Done, sir. Sir, here why can't we write n cos theta equal to mg?
We want n, no? So I followed that.
So, but we can get it n by mg by cos theta would be n then.
No, no, it is not like that. This is mg. You have resolved two components. Huh?
Yes, sir.
If you are resolving n cos theta, n sin theta. n cos theta equal to mg. So as per that, tension will get changed. Na? Hello?
Yes, sir.
So even tension will get changed. So when you take ratio, it will come same. But since we want n, we resolve mg. If we
Okay,
want
sir.
mg, we'll resolve n then. Next. This is again inclined plane. Now we have fully connected to this plane at the top end. And this is one block, string is tied, need to pass over pulley. Another weight of 3 kg is suspended from free end. This weight is 5 kg. We want this angle is theta. So find theta, tension, normal reaction. Three things. Tension is acting away from body. Tension is acting away from body. This will be 3g acting downward. So from this part you can find T equals to 3 times G. That means T equals to 30 Newton. So at least you got tension. Now normal reaction is perpendicular. This is 5G. We can resolve into two components, 5G cos theta and 5G sin theta. So normal reaction N will be 5G cos of theta, that is 50 cos theta, equation 2. And tension T, hello, hello,
Yes, sir. Yes.
so just copy this one to clear that now. Since T will become 5G sin theta, so 30 equals to 50 sin theta, 3 by 5 is sin theta, therefore theta becomes 37 degrees. So we got tension, we got theta. Last one, normal reaction is 50 into cos 37, 4 by 5. Normal reaction.
Um,
One more. This is one block of mass capital M. On that we have small block of mass small m. What is normal reaction between block and normal reaction between surface and mass? Normal reaction between blocks and between surface and mass capital M. Can you tell? What will be normal reaction here? and normal reaction here. See, on this normal reaction will be only due to this mass. So if this you call N1 and this you call N2, then N1 will be mg and N2 will be m plus small m into v. Clear?
Yes.
Because when 2 blocks, 3 blocks question comes, normal reaction, remember, the lower blocks will always have higher normal reaction. As you go up, normal reaction will start reducing. Orally, can you tell me if this is 1 mass, 2 kg, this is 3 kg, this is 5 kg, what will be the normal reaction here? All the masses ka sum na?
Yes.
Yes, sir.
10g here, 5
8G.
नहीं खाली ऊपर ना 3 2
Yes, sir, sorry. 5.
और इधर 2 का वजह से 2.
2G.
So today we stop here. Please prepare for your evening test. Tomorrow we'll meet 12 o'clock because I think 1 student का lecture रहता है.